Okay, so now we are going to take a look at solving systems still by graphing, but weird things might happen on this sheet. Okay, so I'm not going to tell you what they are. You're going to go ahead and do it just like we have been. And when the weird things happen, we'll talk about them. Okay, so in the first one, I have x equals 2. So again, hopefully when you see x equals 2, you're thinking right away, boy, Vux, and you're asking yourself, okay, well, which one of these is it going to be? It's got to be Vux, right? Because I have the x equals, so we'll cross out the hoy, and V is for vertical. So that just means I'm going to have a vertical line at 2. So let's use that line tool, and we'll draw a vertical line at 2 as best we can. It's as best as I can do right now. Okay, now let's try the second one. We'll do that one in green. And that one, you could graph that by intercepts, if you remember. So you could cover up the X and cover up the Y, and they both come out as 4s, or you can do like we have been doing and rewrite it into slope-intercept form. So to get there, I would just minus that X over. So that's your choice. If you want to graph by intercepts, go for it. If you want to rewrite it into slope-intercept form, that's totally fine too. Either way, you're going to get the same answer. So we're going to start at 4, and then we'll follow that slope of -1. So we'll go down 1 over 1, down 1 over 1, and there is my intersection right there. So let's go ahead and graph that as best we can. Ooh, okay. So it looks like my intersection for this one is at 2, 2. So nothing too weird happened in this one, besides having a perfectly vertical line, but that's fine. All right, so let's try another one and see what happens. So if we scroll over to number 2 here, let's just check this one out and see if anything weird happens this time. So let's go ahead. So the top one, you can do that with intercepts if you want. They're both going to be -1 if you cover them up. If you want to rewrite into slope-intercept form, go for it. Whatever floats your boat. There we go. So I'm going to start at -1, down 1 over 1 for this. Okay, and I'll do a couple back here. Because remember, I don't know if it's going to, where on the grid it's going to cross. Use my line tool to connect all those. Not too bad. And then we'll do the bottom one in blue. Okay. So x plus y equals -2. Let's go ahead and minus that x over. Oops. Again, you could have done this in intercepts, but using the x and y intercepts, that's totally fine. So this one's going to start at -2, and then it's going to go down 1 over 1. Okay, I'll do some over on the left-hand side. Looking for that intersection point. Are you noticing something weird yet? They never overlap. Why not? What do you call these two lines? Hopefully you're thinking in your head parallel. Yes, these are parallel lines. Those are two lines in the same plane that do not intersect each other. So there is never going to be a solution to these because they never intersect. So in number 1, you saw that we wrote our answer as an ordered pair. Here, there is no ordered pair to write. So you're literally going to write no solution. And there is no solution because the lines are parallel. So for future reference, how do you know that two lines are parallel before you even graph them? Do you remember talking about the slopes having to be, hang on, let me switch to my highlighter tool. Okay, let's try this. The slopes. So in this case, a -1, and in this case, a -1. The slopes have to be the same in order for the lines to be parallel, but there's a little bit more to it. You also have to look at the y-intercept. The y-intercepts have to be different. Okay, so you need the slopes to be the same and the y-intercepts to be different. That's how you get parallel lines. So you could actually know that they're going to be parallel before you graph them if you happen to take a look at the slopes and the y-intercepts. Okay, so there you have it, our first weird thing. So these have no solution. Okay, let's try another one, see what happens. Okay, let's go ahead and scroll over to number 3. Okay, so these are both already written in slope-intercept form, so they're good to go. And just like we were just talking about, I already know the answer to this one. I don't know if you know it, but I know it. Why? Because I'm looking and I see they both have the same slope and they have different y-intercepts. So what are they going to be? They're going to be parallel. I'm going to graph it anyway, just to be sure. So the top one starts at a +1, and then that one would go up 4/3. So let's go up 4/3. I'm also going to go down 4, back 3, just to have this other point. Okay, create my line through those as best I can, and then I will switch to blue for the other one. And that one's going to start at -4 and then go up 4/3. So that third one would be right about there. So as you can see, wait, that graph was actually, that line was not very good. Let's see if I can do better. That one's not good either. Hold on. That's it. Okay, so another one, I have 2 lines. They are never going to intersect, so these are going to be parallel again. So what do I write as my solution? I write no solution. Remember, you can't do things like leave it blank, because blank means you don't know. You do know what the answer is. The answer is that there isn't one, so you need to say that. Okay, let's just try number 4. And see what happens with number 4. Okay. So it looks like the top one's ready to graph. It's already in slope-intercept form. So I'll go ahead and do that. It starts at 2, and then my slope is 4. So I'll go up 4/1. I'll also go down 4, back 1, and down 4, back 1 more, just to have that all done. Okay, so, oof, hold on. Gotta do that one over. That one was not very good. There we go. That's pretty good. All right, so there's the top one. The bottom one is not ready to graph yet. It's not in the right form, so let's go ahead and get it in a form that well, I mean, I guess you could do it with intercepts if you like. Cover up the X, cover up the Y, solve for H1, you get your 2 intercepts there. But this one would involve a fraction, so I wouldn't advise you doing that. Okay, so let's get the Y by itself. We're going to add the 8x to both sides. And now I just have to, oh, jeez. My cat is walking all over my keyboard and he just knocked something over. Oh well. Okay, so I have a -4x plus 2, right? Okay. Oh. And I'm realizing now that I did something wrong. Oh, darn it. I think I have a typo. I made this problem and I think I added a negative where I didn't mean to. Oh, shoot. Yeah, I made a mistake on this one. I'll try and fix it in your copy. But here's what I want it to be. I want it to be, hold on, let me switch to black. In the original, I want this to be a +2y. Darn it. I was trying to be so careful too. Okay, so if that's going to be a +2y, let's go back over here. If that's positive, that means all these are positive. That means that's a positive. So my final equation is supposed to be y equals 4x plus 2. Oh, sorry about that. But when I go to graph this one, so let me switch back to green, 4x plus 2. Well, what do you notice? Start at 2, go up 4 over 1. Oh my goodness. It's the exact same line, you guys. Exactly the same. So not only does it have the same slope, it has the same y-intercept also. It's literally the exact same line. Well, oh, shoot. Switch back to pen. Y equals 4x plus 2, and my top one was y equals 4x plus 2. So that can happen. At first glance, I had no idea that they were the same, right? Because they weren't in the same form. So once I realized that I have literally the exact same line, the answer is infinite solutions. Because remember, guys, lines keep going forever and ever in both directions. So this thing does not just have one answer. There's not just one spot where they intersect. There's an infinite number of places where they intersect. Everywhere on this line, they intersect because it's two lines exactly on top of each other. So every single point is a solution. So there's tons of them. Here's actually a point that I kind of want to make. Sometimes kids make the mistake of saying that the answer to this is all real numbers. That's not true, because let's just take the point 3, 2 right here. That's not on either of those lines. So the point 3, 2, well, that's in the real number system, but that's not a solution to the system. So you don't ever want to say all reals for something like this, but you do want to say there's an infinite number of solutions. There are tons of them. It just doesn't happen to include 3, 2. It does include, let's see, 0, 2. It includes 1, 6. It includes, I kind of drew over my dots, but I think -1, -2 is an answer. There's tons of them. You can keep going forever, but you won't have every single ordered pair in the whole wide world. Does that make sense? I hope so. So I will try and edit that to make sure that that's a plus 2y and not a minus 2y. But otherwise, go ahead and try the rest of these. And you just have to submit the picture of the bag. You don't have to submit the ones that we did together. All right? Okay. See you soon. I hope